All right, for this lesson, we're going to go over geometric sequences, which is lesson 1.3. I'm going to kind of watch my time, and I may do this in one video, or I may split it up in two, so we'll just see what happens here. So geometric sequences are kind of similar. If you understand arithmetic sequences, geometric sequences are very similar, just one main difference. So a geometric sequence is a sequence in which the ratio is constant, which basically means that we multiply. And so that number that we multiply by is called the common ratio. And the variable that we use for common ratio is r. And one way, it's a little harder to figure out what the ratio is sometimes. So a way that you can find the ratio is you take any term and you divide it by the term before it. And that'll tell you the ratio. Sometimes your ratio will be a fraction or a decimal. We prefer to write them, if it's a nice fraction, like if it's 1/3, your decimal would be 0.3333. So you need to write 1/3 as opposed to 0.3. So we're going to look at all of these examples, questions 1 through 6, and we're going to determine if it is geometric or not. So when we're determining if it's geometric, you have to check all of the numbers that you're given. You don't just look at the first two terms. You have to check that ratio all the way throughout. So if I'm looking at number 1, from 6 to 12, yes, I add 6. But from 12 to 24, I don't add 6. So that's not arithmetic. With arithmetic sequences, you added the same number every time. So like on the test, you will probably be asked to determine if it's arithmetic or geometric. So you need to check, does it add all the same time or does it multiply all the same time? Or none, neither, or maybe neither. So if it's not arithmetic, so let's check geometric. How do you get from 6 to 12? Well, that one, you should be able to determine that one on your own. So 6 times 2 is 12. And I'm going to change that because that looks like 0.2. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So yes, because it did multiply by 2 every time, yes, it is geometric, which means that r is 2 because it's whatever you multiply by. And then we had to find the next 3 terms. So if I take 48 times 2, you get 96. Times 2 is 192. And then multiply that by 2 and we get 384. Let's look at number 2. So is it geometric? So notice your numbers are going down. So when your numbers are decreasing, that you're going to have a fraction. So right off you might be like, I don't know. So I'm just going to calculate it. So in your calculator, so let's just go to my calculator. I'm going to take any term. So I'm going to take 270 and I'm going to divide that by the number before it, which was 810. And notice how it gives me a decimal. We don't want to use a decimal. We want to change that to a fraction. So math, if you go to math and then you hit that number 1, math enter, and then enter again, is 1/3. So from 810 to 270, of course, we multiply by 1/3. So if you take 810 and you multiply that by 1/3, you're going to get 270. Now let's take the next one, 90. And this time I'm going to actually put a fraction in. So I hit alpha y equals, and then I hit enter for that first one. And I'm going to take 90 divided by 270. Oh, sometimes if you put in the fraction, it'll give your answer in a fraction, but this time it didn't, so that didn't help me at all. I could have just done 90 divided by 270. And that does give me the same 0.3333, which is 1/3. And then if you do it again, 30 divided by 90 also gives you 1/3. So yes, it is geometric because I multiply by the same thing each time. My R is 1/3. And if I keep taking 30, if I times that by 1/3, we get 10 times 1/3 is 10 over 3. And then if we do it again, we get 10 over 9. I just keep taking my term and timesing it by 1/3. That's actually the same thing as saying divided by 3. So I want you to take questions 3 through 6. I want you to pause the video and see if you can answer them. If you get stuck, just hit play, but try them on yourself. If you just kind of follow along barely and just write what I write, you're going to struggle. You won't retain the information as much. All right, number 3, you should have found that yes, it is geometric. The R is -5. You're multiplying by -5 each time. And so the next 3 terms, -1250, positive 6250, and -31,250. Number 4, this one is no. We do not multiply by the same thing every time. 4 times 8, or 4 times 2 gives me 8. Well, 8 times 2 is 16. So if you're going and you realize right off that it doesn't multiply by the same, you don't have to keep going. You only have to keep going if you keep getting the same answer. All right, number 5. This one is yes. R is -1/4. So if you take -1 divided by 4, you get -1/4. 1/4 divided by -1 is -1/4. And keep going, you get -1/4. The next 3 terms are 1/64, -1/256, and 1/1024. And number 6, it is yes. That 3.2 probably kind of threw you off a little bit, but if you follow that formula type, not really a formula, but if you take a term and divide it by the one in front of it or the one before it, every time you get R equals 2.5. And 125, 312.5, 781.25. Those are the next 3 terms. All right, so just like with arithmetic sequences, there is a specific formula for you that you'll use to find your formula, and that formula will help you find any term in the sequence. So if I'm asking you to find the 5,000th term, you're not going to want to keep multiplying 5,000 times. So the formula helps you. And this one actually is a little better because there's no like distributing and solving to do, like with the arithmetic sequences. So A sub n, that means any term. When you see the A and the N, that's just some random, any term in the sequence, equals A1 times R. Now, it's really important to put your R in parentheses, and we'll get to an example in a little bit why that's important. But it's just get in the habit of putting the R in parentheses. And then you have n minus 1, but the n minus 1 is in the exponent. So make sure you are clear in your notes when you're writing this formula down. Make sure you're very clear that that n minus 1 needs to be in the exponent. And just a reminder, A1 is the... Okay. My iPad's a little crazy. A1 is your first term, and R is that common ratio. All right, so we're going to do, I think I'm actually going to just do these 3 examples, 7, 8, and 9, and then we'll stop here. And if you feel comfortable and you just want to keep going and you want to pull up the next video, that's fine. Or you can kind of stop and work on your other classes. I know it gets a little hectic for you. All right, so the directions say to write a rule for the sequence. When you say write a rule, that's just writing the formula. So we're going to write a generic formula, and then we're going to use that formula to find the term that it gives us. So for the first part, when we're just writing the rule, we're only looking at the sequence itself. So we start with A sub n equals, it's A1. So 1, my first term is 1, times your R. What are we multiplying by every time? 5. We're multiplying by 5, and then n minus 1 is in the exponent. And now we're going to use that formula to specifically find A sub 7. So we're going to write A7 equals 1 times 5 to the 7 minus 1 power. So I'm going to go to my calculator and I'll show you just this time. 1 times, I'm going to put my 5 in parentheses, and then to do your exponent, it's that little, it looks like a part of a triangle that's above your division sign. And then we're going to put 7 minus 1. And that gives us 15,625. All right, number 8. A sub n equals, our A1, our first term, is 130 times, and then our R, our common ratio. What is that? Now, if you look, you should realize that the numbers are getting smaller, so it's probably going to be a fraction. So I'm just going to take 65 in my calculator and divide that by 130. And I get 0.5, which I know is a half. I would be okay if you just did 0.5 here. Doing a decimal is okay if it's a clean, it stops. But for example, 1/3 is a repeating. It goes 0.33333 and it repeats forever. So you can't round that to 0.3. So that's why using fractions are typically better. I know some of you just prefer, it's harder to type that into the calculator. So if it's just like 0.5 or 0.25, then you can do the decimal. And then we have, in the exponent is n minus 1. So a sub 6 equals 130 times 0.5 to the 6 minus 1 power. And we get 4.0625. All right, number 9, last one we're going to do for this video. A sub n equals A1, which is 2, times our R. If you're not sure what your R is, take any term. So I'm going to say negative 8, and I'm going to divide that by the one before it, and I get negative 4. Check another one. 32 divided by negative 8 is negative 4. Negative 128 divided by 32 is also negative 4. So my ratio is negative 4. And then the n minus 1 goes in the exponent. So now I'm going to find the 8th term. This is an example where those parentheses have to happen. Anytime your ratio is negative, you have to put it in parentheses. And I just prefer you to go ahead and use parentheses all the time, just to, because if you're not in the habit of it, then you might miss it. So 2 times negative 4 in parentheses, and then in the exponent, you're going to type 8 minus 1. And we get negative 32,768. If you don't get these answers that I get, check to make sure you've got your numbers in correctly, and make sure that this is in the exponent. To get the exponent, this is the button you use on your calculator. It's right above the division button. All right, so tomorrow or whenever, if you're staying on track and you're following the pace that I've set for you, then tomorrow you need to finish these notes. Have a good day.